Hello everyone. Now today we are going to discuss the problems on residue theorem. Okay, to apply the residue theorem we need to evaluate these integrations. Okay. Now to evaluate this integration then we are going to use the residue theorem. Okay. Now first look at the problem. Evaluate integral over c z square by z minus 1 whole square into z plus 2 dz over the curve C is mod z equal to 3 by using residue theorem. Now before going to discuss the problem, first we need to understand what is the curve they given. Okay, they given the curve mod z equal to 3. It means that they given a spherical equation, then simply mod is 3, nothing but radius is 3. Okay, now is center at 0, 0. Now radius 3 units. Okay. Now like that it goes for a circle. Okay, now center at 3 units is simply here also 3 units, the length here 3 units, here 3 units. Okay, now is a curve they given. Now next we need to find out the how many simple poles or pole of order, how many singular points we have, that we need to know it. For f of z we have z square by z minus 1 whole square into z plus 2 at z equal to 1 and z equal to minus 2 at the singular points. Now when you want to expand this, you should be have for z minus 1 whole square, right? Now simply you can have the negative power of z minus 1 is minus 2. Then when you look at the power, easy to recognize the pole. Then z minus 1 whole square we have, that's why is pole of order 2. Okay, now z equal to minus 2 here. Now that is also singular point. You can have only power 1, simply is a simple pole or simply pole of order 1, both are same. Now z equal to 1 and minus 2, they both are inside. Okay, z equal to 1, here we have. Now z equal to minus 2, here we have here minus 3, the radius we are up to 3, right? Here minus 2 and here we have 1. Okay, now both are inside. Okay, inside the given curve mod z equal to 3. Okay, to evaluate this integration, then we need to find out the residue set only inside point of the given curve. If you have other point, for example z equal to 4, okay, here you have z minus 4, if we say is a factor, now z equal to 4 is outside point, right? By residue theorem, the all singular points should be inside. Okay, if we have the outside point, now no need to consider for that point to find out the residue, only consider inside points to find out the residues. Okay, now that residues we are going to use to find out an integration value. Okay, now first I find out the residue at z equal to 1. Okay, now is a pole of order 2, they simply use the second point, that residue of a, the 1 by n minus 1 factorial d power n minus 1 by dz power n minus 1 z minus a whole power n into f of z at z equal to a. Now this is a formula we have for pole of order n. Okay, now is a pole of order 2, nothing but n equal to 2. Now that we need to put it here. Okay, now I will substitute that n equal to 2 in this box. Now residue at f of 1 is 1 by 1 factorial d power 2 minus 1 is 1. Okay, here also 2 minus 1 is 1, here 2 minus 1 1. Okay, now d by dz of z minus 1 whole square, a equal to 1, right? Now z minus 1 whole square into f of z. F of z is total term. Okay, now that you are substitute here. Now z minus 1 whole square, z minus 1 whole square cancel. On the remaining term, you can apply for the derivative. Now remaining term z square by z plus 1, z plus 2. Now apply derivative of this, simply apply u by v formula. Now denominator v square, now u dash, z square derivative is 2z, z plus 2 as it is, minus, now z square as it is, z plus 2 derivative with respect to z is 1. Okay, now this we need to find it at z equal to 1. Substitute z equal to 1 here 2 into 1 plus 2 minus 1 square is 1 by 1 plus 2 whole square. Okay, now it's totally 5 by 9. Now next we need to find the residue at second point at minus 2. Okay, now residue at minus 2. Now is a simple pole, right? Now is the first formula that limit z tends to minus 2, z minus a is minus 2, right? Minus 2 into z square by z minus 1 whole square into z plus 2. Now here minus into minus plus 2, right? Z plus 2 into z square by z minus 1 whole square into z plus 2. Now z plus 2 will cancel. Now remaining on, you can apply z equal minus 2 whole square by minus 2 minus 1 whole square, it become 4 by 9. Now to apply the residue theorem. Residue theorem, we have integral over c f of z dz equal to 2 pi into sum of the residues at a singular point. Now all that points should be inside. Okay. Now here we have the two inside points that are 1 comma minus 2, 1 comma minus 2. That's why we use for all inside point. If you have any one point we have for outside, then don't consider the outside point to include in residue theorem. Okay. If you find for residue, okay, but no need to substitute in a residue theorem. Okay. Now only inside point residues you can apply in a residue theorem, then get the evaluation, right? Now is 2 pi into first residue at f of 1 is 5 by 9 plus minus 2 is 4 by 9. The sum is 9 by 9, will cancel. We have 2 pi into 1 is 2 pi. Now this is a way to find the integration, then integral over c f of z is equal to 2 pi. Now other problem, second one, evaluate integral over c tan z dz, where c is a circle margin equal to 2. Okay. Now tangent can be sine by cos. Okay. Tangent can be, here we have tangent can be sin z by cos z. Okay. Sin z by cos z. Now to get a singular point, they simply make it what denominator is 0, cos z is 0. Now z we have plus r minus pi by 2 plus r minus 3 pi by 2 plus r minus 5 by 2 plus and so on. Now here we have so many points we have where cos z is 0. Now we need to pick up the points where the point belongs to the given curve. Okay. Now the given curve here is circle margin equal to, now is a circle equation, center at 0, 0, radius 2 units. 2 units. Okay. Now here z we have first value plus pi by 2. Let's say pi by 2. Pi by 2 is pi is 3.14 by 2 is 1 point something is belongs to inside. Now minus pi by 2 is also minus 1 point something inside. 3 pi by 2 is 3 into 1 point something. Pi by 2 is 3.14 by 2 is 1 point something. 3 into 1 point something is 3 point something. Okay. Now it should be 3 pi by 2 is more than half 3. I think our circle equation we have only margin equal to 2. Now this value more than half 3 simply is outside. 5 pi by 2 also is more. This value is 5 point something. Now is more than half 2 is also outside. Next we have 7 pi by 2, that also outside. All other points are outside the given circle margin equal to, except these points plus pi by 2 and minus pi by 2. Therefore z equal to plus pi by 2 minus pi by 2 are simple poles are inside margin equal to 2. Okay. Now we need to find out the residues at pi by 2 and minus pi by 2. Now first find the f of pi by 2, residue at f of pi by 2. Now to find this, now we can't able to write that f of z. Well, let's say the simple pole formula that we have here, z minus a, the previous problem I discussed, z minus a into f of z. You can write for the f of z as a factor of z minus a, simply they are cancelled to get the residue. But here we can't factorize this pi of z, we can't factorize the sin as z, cos of z as a z minus pi by 2. That is the reason we use the second formula that then if given f of z can be written as for pi of z and psi of z, then we use the residue formula, limit z tends to a pi of z by psi dash of z. Okay, now that formula I'm going to use it here. Limit z tends to a is here pi by 2, pi of z by psi dash of z. Pi of z is sin z, psi dash of z, psi of z is cos z. Its derivative is minus sin. Okay, now sin z cancel, z equal pi by 2, nothing but the z cancel. Here we have only 1, right? Minus 1. Now with the term independent of z, we can't apply the z there. Simply the limit value is minus 1. Now simply use the residue minus pi by 2. Now get the integration value. Now similar as you can find for z equal to minus pi by 2 residue. Okay, now that is the residue of minus pi by 2 equal to limit z tends to minus pi by 2, pi of z by psi dash of z. Same, pi of z is sin z, psi dash of z is minus sin z. Will cancel, we remain minus 1. Now by residue theorem, integral over cf of z is 2 pi into sum of the residues. Now first residue at pi by 2 is minus 1 plus second residue at minus pi by 2 is minus 1. Totally minus 1 minus 1 minus 2 into 2 is minus 4 pi I. Okay, now integral over c tan z dz equal to minus 4 pi I. Okay, now this is a way to find out the integration values. Okay, now most probably we can use all three formulas here to know the integration. Okay, thank you.